Welcome to another video from explainingcomputers.com. This time I'm going to show you how to run a Gemma 4 local AI model in an application called LM Studio. Both of these are free and allow us to run AI privately without accessing the cloud. For the best AI performance, a computer needs a powerful graphics card. But most people don't have this kind of hardware. And so, in this video, we're going to run Gemma 4 on a computer with a similar specification to many laptops and mini PCs. Gemma 4 is a family of open AI models from Google DeepMind. 5 different sizes are available, known as E2B, E4B, 12B, 26B and 31B. Here B stands for billion parameters, with the larger models being more capable but requiring more computing resources. As we can see, the E2B and E4B models are designed to run on mobile and IoT hardware, although they're also suitable for less powerful laptop and desktop computers with modest RAM. Meanwhile, the 12B, 26B and 31B models are designed for personal computers. Of these, 12B released in June 2026 and is designed for laptops. And, as this suggests, it can run on hardware without a dedicated GPU. All Gemma 4 models are available in different levels of precision, ranging from a default of 16-bit down to 4-bit versions that are compressed using a method called quantization. In June 2026, Google also released models optimized with quantization-aware training, or QAT. Rather than compressing a fully trained model, which can degrade accuracy, QAT integrates quantization simulation into the training process itself, which allows the model to learn to compensate for precision loss. Here, we're therefore going to choose a QAT version of our Gemma 4 model. However, some issues have been reported when performing text analysis or coding. So, if a QAT model gives you problems, try switching to one based on post-training quantization, or PTQ. To help us select our model size, Google provides this table. Note that this shows the free memory required to load what are called an AI model's base weights. In addition, system RAM is therefore needed for a computer's operating system, the AI software that will be used to run the model, and the AI model's working memory or context window. So, if you're going to run Gemma 4 on a computer without a dedicated graphics card, you'll typically need to add at least 4 GB to these numbers when comparing to your system RAM, although the exact figure depends on several factors. In this video, we're going to run Gemma 4 on this Ryzen 5 5600G PC with 16 GB of RAM. I've chosen this test system because, like most laptops, it has integrated graphics rather than a dedicated GPU, and so using it will give us a good idea of Gemma 4 performance on typical mid-range hardware. For a computer like this one with integrated graphics, I would recommend a 4-bit Gemma 4 model. And so, given our 16 GB of RAM and accounting for OS and other overheads, we're first going to try Gemma 4 12B 4-bit and see how fast it runs. And if 12B 4-bit is too slow, another option could be E4B 4-bit, which is less capable but will perform faster. To run Gemma 4 or any other local AI model, we need some execution software. And here we're going to use LM Studio. This is free for home and work use and provides a graphical interface for downloading and interacting with local AI models. LM Studio is available for Windows as well as Mac and Linux. And here we're working in Windows, hello, and so we'll download for Windows. And having done so, we'll install the software, which involves accepting a license agreement, and will install for anyone who uses this computer. and tell Windows that installing LM Studio is OK. After which we seem to be back to a license agreement, following which we can finally click on Install. And there we are, we now have LM Studio on our computer. So I'll just close down the browser to be tidy, and then we'll click Finish, which as we can see will run the software. And here it is saying hello. And it's worth knowing you can change the scale of the interface using Control plus and minus, so we will do a little bit of that, which brings up the Get Started button down here, which I will click. After which it gives us the option to install our first AI model. And there's no reason you shouldn't do this, but I'm going to skip this for now because I want to show you the full model search functionality. So I'm just going to turn off Start Local LLM on login. I don't necessarily want that. And we'll click to continue to LM Studio. And here we are in the interface, where to install a new model, we go across to the fourth icon down over here, which is Model Search, and we will click on that. And oh look, lots of models are available. And these include a number of staff picks, the top one of which is Gemma 412B QAT, which we decided to install earlier. And we can see over here the files available. If we click here, we can see there's only one file, Gemma 412B QAT, and it is the 4-bit version. Although down here we've also got the standard Gemma 412B, where if we click to see the available downloads, there are 4-bit, 6-bit and 8-bit versions based on post-training quantization, or PTQ. And very helpfully, LM Studio is telling us that these two latter files are too large to use on our computer. But what we decided on is Gemma 412B QAT, and note if this hadn't have been here as a staff pick, we could have searched for it using the search box. But we don't need to do that, so we can now just click on download for the 7.15 gigabyte file. And as this is quite a large file, we'll use the magic of filmmaking to speed on through. And there we are. We now have LM Studio and a Gemma 4 AI model locally on our computer. There are, as you could imagine, various settings that we could tweak, but for now, let's jump straight in to our first chat. And to do this, we can just click on Use in New Chat, and the model will load up, which as we can see, it's done successfully, and we can now chat with our new local AI. Before which, I'm just going to scale up the interface with Control+. There we go, and let's ask a polite question. How are you today? Which causes the AI to think, taking a little bit of time. Maybe it thinks it's a complicated question, but there we are. And clearly, on default settings, Gemma 412B is not lightning fast on this system. But fear not, as we're about to see, there are things we can adjust to speed it up. And there we are, we do have an answer. It says, I'm doing well, thank you for asking. How are you doing today? Is there anything I can help you with? To answer our first question, Gemma 4 spent about 18 seconds thinking, and if we hover over this watch, we can see it achieved a speed of 5.46 tokens a second. A token is the basic unit of AI language processing, typically equivalent to about 4 characters or 3/4 of a word. And obviously, we want tokens per second to be as high as possible. At this point in the video, I was therefore planning on going through lots of different performance settings. But to be honest, LM Studio is very good at setting defaults, particularly on systems like this one with integrated graphics. And so I'm not going to spend 5 minutes going through all the settings, because there is a way of speeding things up that doesn't involve them. Although it is worth just noting that it's wise to go to settings and turn on developer mode like that, which allows you to click on hardware and just to check that your system's been correctly identified and your GPU has been turned on, which it has here. And there are settings for individual models. You can click on the gear icon next to a model. Lots of settings are available, but I'm not going to go through all of these because this is a beginner video, and to be honest, LM Studio sets the defaults very well Indeed, I've tried playing around for hours and obtained very little performance improvement. So what I'm going to do is to leave some notes in the video description about model settings and move on to the thing that makes a dramatic difference to Gemma 4 performance. Oh, and just note we've now got permanently displayed on the screen our statistics because we're in developer mode. Anyway, the thing I'm going to focus on now is that Gemma 4 has what's called a thinking mode. And what this does is to perform a chain of thought reasoning to break down each request with an internal monologue. We can see it up here. Here's what it was thinking about when it looked at that initial request. And it does this to improve the final answer. But this thought process also takes a lot of time. It took 18 seconds for this initial query. And so guess what? We're going to turn off thinking mode by clicking the toggle down like that. And for simple tasks, this should have little impact on results, although you may want to turn thinking mode back on for things like coding or agentic computing. But with it turned off, let's have a clean window. Let's do a new chat and ask it exactly the same question we asked before. How are you today? And before it took a second, this time it's going pretty much straight to answering. It is massively faster than it was previously. This said, on this system, Gemma 4 is clearly not as fast as Google's Gemini or ChatGPT. However, it does have the advantage of running entirely offline. Indeed, it's important to stress that Gemma 4 does not upload anything or obtain any information from the internet. And to prove this, if we just minimize the window, you'll see this computer is now offline. We don't have an internet connection. And I wanted to show you that because we're now going to give Gemma 4 a practical task, which will be this. Write about 100 words about southern Italy. There we go. And as it doesn't have thinking mode, it's going straight into the answer. And this is, I think, pretty rapid. And I do find it amazing that it's generating this answer based entirely on the knowledge contained in its 12 billion parameter large language model. This is, to me, amazing. Here we've got this chunk of data we've loaded in, about 7-8 gigabytes, whatever it was, and it can answer all kinds of questions. And this looks pretty good to me. It's a potentially useful thing to be able to do. It's also worth noting that Gemma 4 is multilingual, supporting over 35 languages out of the box. And this means we can also do something like this. Translate your last answer into French. There we go. It's translating its last answer into French. Taking a little bit of time to think about it, but it's a useful practical task. And there it goes. It's giving us the answer in French. It hasn't gone online. Again, it's doing it based on the knowledge contained in its LLM, in its large language model. I don't know if this is right or not because I don't speak French. I tried to learn French at school, but I was never good at languages. I could do science and maths and economics, that type of stuff, but never got on with languages. But anyway, it does look like it is producing something that looks like it might be correct. I'm sure someone in the comments will tell us whether it's correct or not. But there we are. We've demonstrated what I think many people would agree is a practical application for Gemma 4. In addition to direct text input, Gemma 4 can work with images and text files. So let's test that by loading in an image. We will load in mystery animal AA, and this is mystery animal AA, and I'm sure you can guess what I'm going to do. I'm going to say, what is this animal? And it'll have a think, and whilst it does it, we will speed on through, and there we are. The animal is a giraffe. It's got it correct. But we'll give it something a bit harder. Another image, mystery animal BB, which is this one here, and once again we'll say, what is this animal? See what it does this time. And there we are, it's got that correct as well. It knows that this animal is an okapi. So let's now test working with a text file. And so what I've done over here in Notepad is to put the text of a chapter from one of my old books. So we will load it in. Let's attach file. And it's worth noting that whilst Gemma 4 does not natively support any file formats other than a pure TXT file, if you use it here in LM Studio, you can bring in PDFs and docs, which is very handy. Anyway, for now, we'll just bring in a standard text file. There it is. And what I'm going to say here is summarize this document in about 200 words. And it'll start doing that. It's telling us it's injecting all of the content, the full content, and that all content can fit in the context. And I'll come back to what that means in a second. But first, we will speed on through. And there we are, it's finished. It's produced what looks like a pretty decent summary of what was a 3,900 word document, knocked down to 200 words. To return to what it said about context, this refers to the model's context length, also known as its context window. And this is the maximum number of tokens that a large language model can work with. And down here, we can see that now 65.9% of the model's context of its short-term memory is currently being used. When working with text files, this is also something you need to be aware of because you may need to increase the context to work with larger documents. And you can do this in the settings we saw earlier, or we can just go up here to the gear icon where we can see that a default value has been set of 8192 tokens, which is about 6,000 words. So if you wanted to summarize a 10,000 word document, you'd have to increase your context length. However, do note that a longer context length will consume more memory and decrease performance. So only increase it if and when necessary. Oh, and something else I should point out is that if you want to take a copy of text that's been generated by the AI, you can go down here and click on copy and then paste the text into any application you desire. Right, something else that Gemma 4 can do is to write code, and so to demonstrate the basics of this, I've got here the Python IDE, and we'll go across to LM Studio where I've written a prompt which says write a Python program that asks for somebody's height and weight and calculates their BMI. So there it goes, writing our program, and it'll take again a little bit of time, so we'll let it speed on through. And there we are, in about 1 minute 50 seconds, it has responded to what we asked, it's told us what it's going to do, it has written the code, there it is, and it's told us how it works and given us some example output. So all we need to do is to go back to the code here and click on copy. There we are, to go back to our IDE and paste in the code like that, and let's scroll to the top to be tidy and also just save like that. And we can now run the code. We could press F5, but we'll run module like that. And it says enter your weight in kilograms. Let's enter, I don't know, 72. Height in meters, 1.76. And there we are. BMI is 23.4, category normal weight. And it is, I still think, amazing we can use computers these days to write code. I know it is controversial, it raises all kinds of issues, but it is impressive you can do this on a local AI model running on a computer without a dedicated GPU. As mentioned earlier, a smaller model will run faster on the same hardware. And so I've now downloaded a 4-bit E4B Gemma 4 so we can compare it to the 4-bit 12B we've been using. Now in chat we therefore have a choice of which model to use, and so here we'll load in Gemma 4 E4B. So let's ask it some of the same questions. How are you today? I've got thinking off as previously, and as we can see that came up very quickly. It's giving us a totally different answer, and it's given us a speed of 11.75 tokens a second, which compares to 6.0 the last time we ran it in 12B. So the smaller E4B model has come out about twice as fast. So let's repeat our animal identifications. Here we go. Can it identify a giraffe? Remember, it's a less capable model. We'll see. We'll do this in real time because we've got a faster system now. Still taking a little while, isn't it? Is it going to get there? There we are. Giving us a longer answer than it did previously, but it does know it's a giraffe. And it's giving us lots of information about the giraffe, which is very nice of it. And it's done, what, about 11 tokens a second-ish roughly, compared to 6.45 in E12b. So let's repeat the other animal identification, which was a less common animal, as you may recall. Let's see if it can identify this. What is this animal? Let's have a go. There may be a difference. I've not run this yet. It's very exciting to see because we've got a smaller model and that's got to mean less capability. Will it know the okapi? Oh, the suspense is killing us, isn't it? And what are we going to get? I'm unable to identify an animal from the image you provided. Picture appears to be abstract textured background with horizontal lines, etc. Well, clearly, if I can scroll to the right place, that isn't true. It's the same image we had previously. It just can't identify that animal. And I think this nicely demonstrates the broader point that while smaller AI models will deliver more tokens per second on the same hardware, they inevitably may generate less accurate results. As we've seen, free Gemma 4 local AI models can run effectively on relatively modest hardware. Whether this is actually useful depends on what you use a computer for, but I always think it's great to experiment on a new frontier. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.